This is Pre-Calculus Math Analysis Section 7.5, part number 3 of the notes, talking about linear programming. Here's what we did last time, where we have unbounded regions in which there is a minimum but no maximum, and we want to now put it all together into an applied question. There are many applications with linear programming. So here's one. Suppose that Netflix is planning to film a new series. The series requires 60 hours per week total of producing and writing combined. However, producers work a maximum of 40 hours per week. Writers work a maximum of 35 hours per week. The series costs $500 per hour to produce and $300 per hour to write. We have to create an objective function for the cost of the series as a function of writing and producing. Then we want to write down the constraints, graph the feasible region, and then determine how many hours the producers and writers should work in order to minimize the cost of the series. What will Netflix pay the producers and writers to make the show? A ton of stuff going on here, but if you were in a business application, you could imagine yourself trying to minimize some sort of budget in order to reduce cost. Now, cost function. Let's write P for producing, W for writing. Cost of P, W equals $500 per hour plus $300 per hour for writers. Notice that the common denominators here in all of the constraints are time and dollars. So you can imagine that we are going to have a cost function in terms of dollars. The constraints are going to deal with hours. Producers work a maximum of 40 hours per week. So the producers will work no more than 40. The writers will work no more than 35. And then there's one more. The series requires 60 hours total. At least. So here are our constraints in hours. And then this is our cost, dollars. So while the constraints are in hours and the cost function is in dollars, we are actually going to draw our graph, which is going to be in terms of writing and producing. Let's go by tens because of these constraints. So we'll say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let's label it really well. Okay, so one of them, P must be less than or equal to 40. we put producers along the x-axis, so that means that that's going to be a vertical line. Next one. W must be less than or equal to 35. We put that on the y-axis, so this is W equals 35. This one's P equals 40. Third one, P plus W equals 60. So if P is 0, then W is 60, and vice versa. Alright, we've got some sort of region that must be Netflix wants a minimum of hours combined to work on the project. However, the labor, producers and writers, don't work more than a certain number of hours. So that right there is our feasible region. Let's now minimize the cost. There are 3 vertices, A, B, and C. Point A should be where W is 35, but if I plug 35 in for W, I get the P value is going to be 40. I'm sorry, 25. Okay, point B should be 40, 35, and point C should be 40, 20, because it has to add up to 60. These are our vertices, and now let's look at the cost. The cost for vertex A is going to be 500 times 25 plus 300 times 35, and that's going to be 23,000. For point B, it's going to be 500 times 40 plus 300 times 35, and that's 30,500. For point C, 500 times 40 plus 300 times 20, and that's 26,000. So the least amount of cost here is going to be point A. Minimum cost occurs when the producers work 25 hours and the writers work 35 hours. Okay, there you have it. That is our application for linear programming. Please comment on this video in order to earn credit, and then have a nice day.